Hello YouTube, De-bodgery here. I bought this little light kit, little headlight kit on Amazon for 50 bucks. Later on I found it on AliExpress and also on Amazon for a lot less than 50 bucks. So I overpaid for it, but hey, yeah, this particular sales page, they would deliver it in one day after you paid. So, you know, it seemed kind of reasonable to get them quickly because I want to put these on my Dualtron City stand-up scooter. And being that they're very small and so on, I figured this might be a good solution. So I went ahead and bought them, you know, whatever. Seems like a kind of a cool deal because you get these two headlights and they make yellow and white light. And you get this little control, remote control thingy that's wired. And then you get this control box which shows your voltage, and it's got a little blue LED in it, and it's got a USB charging port, stuff like that. They say on here that it's 5 volts, 1 amp. I'm going to say I'm skeptical about that, but I'll talk about that in a minute. Anyway, seems kind of cool, but the real result is you end up with this rat's nest of wires, and it's overly complex, and it doesn't work very well anyway. So let me pull this aside, and I'll show you all of that. So basically, all of this stuff, other than these little caps, which will go on the LED hosts, everything else here is completely eliminated. Almost completely eliminated. Still need those wires right there coming to through the LED caps, but that's all. Almost all. Alright, so here's the little control, remote thingy. So what you're supposed to do is these two little things right here, they light up. It's just a couple red LEDs on there, and if it's lit, then it means it's ready to roll, and if it's not lit, it means it doesn't work, I guess. Anyway, you hold this down, the red button down, and the headlights turn on. Then when you release it, it's on whatever state the LED headlights were on before. So if that's yellow or if that's flashing, I guess that means it goes back to that mode again. You press it again, so let's pretend like it was in white. You press it again, then you get yellow, and then this blue button, you press that, then you get yellow and white at the same time. You press it again, then you get flashing lights, and then you go back to this one to get white and yellow all by themselves. So it's a weird implementation. They could have done this whole thing off of a single button. In other words, you hold it down, and that turns on the headlights, and then it just goes to whatever state it was in last. Then you hit it, and you're just scrolling through the 4 options, and then you hold it down again, and then it turns off. Could have done the whole thing with one button, and instead they chose this weird 2-button operation, which doesn't really make a lot of sense. There was a little control box, and whoops, dropped the other half of it. But it was inside this little plastic box, and inside was this little board. And the board was working kind of weird nearly right away. So it has this little voltmeter display on it, like you saw on the box cover. And I would say that mine worked sometimes. Sometimes it actually display supply voltage, sometimes it wouldn't. Anyway, so that was kind of squirrely. Right up here is a little blue LED. Mine flashes or doesn't flash, depending on the price of tea in China. I have no idea what that LED does, because it just blinks randomly. I can't tell you what that does. Right next to it, there's a little tiny button, a little momentary switch inside there, but there's no access to it from the front cover. I have no idea what that little button did, and it was completely buried in the silicone which it coated this entire board. The only thing that was basically not completely inundated in the silicone was like the tops of these 2 capacitors and then the top of the LED display. Otherwise, everything else was buried, and that was top and bottom. So it took a while to pick all that stuff off to get to the bare board. But anyway, it's got a little 5-volt DC to DC converter on there. Whatever the input voltage is, anything up to 30 volts down to like 9 volts or so will convert down to 5. But the box says it's 1 amp at 5 volts. But I've seen this exact same chip, DC to DC, inductor rather, and capacitor to make up a DC to DC converter, and you can buy them like on eBay or AliExpress for like 75 cents a piece. But in my own testing with them, they really don't ever make 1 amp, so they're probably really only good for about 0.5 to 0.75 amps, so those are ambitious, to say the least. Okay, so that's the top side of the board. The bottom side of the board, I'm pretty sure, whoops, that's a Microchip's PIC16 microcontroller. I think this is probably just a CMOS or TTL logic gate, but I don't know. They've got the tops of the chips ground off, and they did the same thing to the little buck converter chip right here. They ground the tops off of them, so you can't see what those parts are. But I can recognize circuitry for what it is easily enough, and can have a pretty good idea. There's two little shunts right here. They are 100 ohms each, and I'm sorry, 10 ohms each. And those go out to the two wires that power the lights. So those are current sensing. However, they were wired in parallel. Even though there's a separate solder hole for each one of them, the LED wires bridged across both of those things. So whatever. Guess you don't measure current for each one separately. Also, right here and right here were two 4407 P-channel MOSFETs. That would basically power various and sundry things on the board. Well, eliminating this thing, because it died soon after I got it, I hadn't even cracked the thing open yet, and it was already acting weird. And then soon after that, it wouldn't even turn on anymore, so it was time to come out of the case. And I wanted to eliminate all of this nonsense here anyway, because it's just extra crap. And so I knew I was going to get rid of that. And all I needed to do was figure out how to pull that off, which I have. So I knew that this more than likely, switched power to the LEDs through MOSFETs, and sure enough, it does. So I just basically used hot air to reflow those MOSFETs off that board. And in the process, I still wanted to be able to disconnect power from the LEDs somehow. And so I have. And that's this right here. So those two little P-channel 4407 MOSFETs got reflowed onto little SO8 boards. And again, there's two boards right here, and if I spent 50 cents on them, I'd be shocked. Because they're super cheap. You can buy them on eBay, AliExpress, Amazon, whatever, for next to nothing. So anyway, I reflowed the two 4407 MOSFETs, P-channel MOSFETs onto there. P-channel MOSFETs, they need to be biased to ground in order to enable them so that they start conducting. So if you want them to stay off, being that gates of MOSFETs are essentially a capacitor, they'll sort of float and turn on the MOSFET arbitrarily. So you have to pull the gate up to your positive voltage rail. So there is a 1K resistor right here that's doing that, and then you can see two little sections of white wire that goes to both of the gates, and then there's this green wire right here, and that goes over to this toggle switch. And again, this is purely rough implementation until I finish this thing up, which will go on my Dualtron City. But in between time, this is simulating the very, very low current switch that is actually on the Dualtron City that will turn on the headlights. And really all this is doing is seeing maybe 50 milliamps. It's enough to bias past that 1K resistor to pull the gates down to ground. And when that happens, the MOSFETs conduct, and then over here, so that red wire right there comes off of the drain side of the two MOSFETs, and this red wire right here goes over to my power supply, positive side, which probably can't really see that, but it says right there 13.4 volts. It's on, but as you can see, the headlights are not on, and that's because the MOSFETs aren't on. So anyway, the little switch isn't carrying any current whatsoever. It's simply, well, almost no current. It's simply biasing the gates on the MOSFETs. That's it. So these two little driver boards, they have 4 modes in them, like I've already said. It basically works the same way as the tail cap switch does on a flashlight. You have them on, and it goes to whatever state it was in last. And then you bump the tail cap switch, and that pulses the battery voltage to the board, and it senses, oh, there's a change, so then it goes to its next mode. And this works exact same way. So, here's the little toggle switch. You can see the headlights are on. This is a little momentary switch, so as soon as I let go, the lights turn back off again. But, it remembers where it was last, because there's a couple little capacitors on here that take a minute to bleed out. And so the little brain inside there, if you want to call it that, remember whatever state it was in last. So it was in white, now it's in yellow, let it go again, and now it goes to both, and do it again, and now it's in its flash mode, do it again, and now I'm in back to white again, do it again, I'm back to yellow, and I can do this real fast. You know, as quick as I can cycle through them. It'll recognize pretty quick button pushes. But really all I care about is that, you know, it picks a mode and it sticks there. You know, and that I can select it, you know, easily. So on the Dualtron City, there is a locking switch that was for eco mode. And, well, I already thought that the scooter was slow on full power, never mind eco mode. So, you know, eco is not going to get used. So I'm repurposing that switch to turn on these headlights. And it's like a 0.5 amp switch. So it definitely cannot deliver in its contacts enough current to drive these LEDs, which take about 3 amps. So the MOSFET switch, you know, that little guy, is a necessity in order to do all the current carrying for these LED headlights. But they've been off long enough so that, at least I think it has. Let's see. Yeah, it was off long enough for those caps to bleed out and go back to its default state, which is the white LEDs. But yeah, it totally works. And the switch is not carrying the current load. That's totally done in those two little MOSFETs that are on there that I scrounged from here. Yeah, completely simplified things. Took all the complexity away from this thing, you know, which was all this extra junk, and just got it down to the bare minimum needs that are going to work well on the Dualtron City scooter. These little boards, they were just stuffed up inside the hollow space, so you can see my fingers up inside here. It's a pretty good empty hole in there. They were just stuffed up inside there and wrapped in a couple layers of Kapton tape to cook. They really need heat sinking, which is why they've got thermal gap filler underneath them and then zip tied down to the LED shell for the moment. That will change. They will still go back in that hole, but they will also get adhered to that hole so that they have a thermal path rather than just cooking inside there. Anyway, pretty cool. The LEDs are supposedly, according to the Amazon page, you know, 2,000 lumens, but I'm familiar with dealing with real Cree LEDs, and these are, I forget what they're called, ZES-3575s, 3557s, I think that's it, one of those two numbers. Yeah, those are more like maybe 600 lumen LEDs, and maybe 500 for the yellow. And so that's probably like 700 or 750 because it actually powers them both down a little bit to do both. And yeah, that's pretty much the white light is the brightest thing. And I would still say that's like 600 lumens at most, you know, across both of them. Not one. Because a single XHP 70.2 will completely beat both of those. And those only make about 1,300 lumens. So there's no way that each one of these is 2,000 lumens. Not even a chance in hell. Anyway, still pretty decent light, fairly compact, as you can see. It fits in my hand. You know, obviously it won't be a bunch of wadded up wires like this when it's all done. But, you know, pretty decent, small, compact. Can sit here and run for hours, you know, with no air blowing over it and not overheat. So that part's pretty cool. Not worth $50, I can tell you that much. And all of this is junk. Just, you know, crap. Way too many connectors, much too long wires. Everything about that is just yuck. Not going to keep that shit.